Hello everyone, today we can discuss the Leetcode question number 1161, maximum level sum of a binary tree. Basically what they given question, they given root of a binary tree, okay, and the level of root is 1, the level of children is 2 and so on. What the first line tells us, they given root, okay, and the level of root is 1 and its children are 2, means 7 is left child and 0 is right child. We need to return the smallest level x such that sum of all the values of nodes at level x is maximal. Means we need to find the sum of the each level, okay, which is the maximum sum. That level we need to return as our answer. This is the question. See in this example, we can understand the example one. See, this is a root one, okay. After doing sum, we will get one only, and this is a level two, okay. After doing sum, we will get 7. This is a level 3, okay. After doing sum, we will get -1. See, we need to find which is maximum. Here maximum is 7. So, we are returning level 2 as our answer. Okay. This is the example. Let's begin proper understanding the whiteboard. Let's begin understand this example. First, I will be taking two variables. One is level. I will be initializing with 0. And another one is answer. To traverse all the nodes, I will be taking Q data structure. This is my root. Okay. First, I will be push the root in the queue. This one is at the level 1. So, my level will be now 1. I will check now. 1 is my front element. Okay. What I will be doing, I will check if left child and right child are exist. If exist means I will push in my queue. Once left is 7 and once right is 0. Just I will be push in my queue. This 1 is my answer now in the level 1. After that, I will be pop out from the queue. Now my front element is 7, okay. What I will be doing, I will check its left and right child are exist. If exist means I will push in my queue. See, 7's left is 7 and 7's right is -8. Just I will be push in my queue. See, 7 is at level 2. Now the 7 will be stored in my answer, 7. After that, I will pop out from the queue. Now 0 will be the front element. I will check 0's left and right child are exist. Here left is null and right is null. So I will not push in my queue. This 0 I will be stored in the answer. Now I will get 7. After that, I will pop out from the queue. Now front element is 7. I will check left and right child are exist for the 7. Here left is null and right is null. So I will not push in my queue. And this 7 is at level 3. I will be stored in the answer. After that, I will be pop out. Now my front element is -8. I will check its left and right child are exist. Here left is null and right is null. So I will not push in my queue. Just I will be stored in the my answer. I will get -1. After that, I will pop out from the queue. Now we'll check the which is maximum sum. Level 1 is at 1 and level 2 is at 7. So we got it 7 as maximum sum at the level 2. So our answer will be now we are returning 2 as our answer. This is the approach. We can enter into the coding part. We can code it. First base condition, okay. If the root is empty means I will return nothing. Just I will return empty 0. After that, I will be taking one data structure Q, which is of tree node type with the name Q. First, I will push my root in the queue by using push operation. I will be taking three variables. One is answer, sum, and level. Answer I will be initialized with 1, and sum I will be stored the minimum value. Level is at 0 for starting. Now I will take one condition. If the queue is empty means it will not work. If the queue is not empty means the condition will be work. That logic I will be right now. If the queue is not empty means I will increment my level. Next, I will store my queue size in a size variable. I will be taking one temporary result. I will be initializing with 0. Now I will traverse each node's level wise. For that reason, I will be taking one for loop to traverse all the nodes. Here I will be taking one node variable which is of tree node type. I will store my queue friends in that. After that, I will be pop from the queue. In the result, I will be store the node value. If the node as left child and right child exists means that also I will be push in my queue. If node's left child is exist means just I will by push operation I will push in my queue. After traversing all the nodes, I will come out of the for loop. I will check my temporary result should be greater than the sum. Then I will update my sum. Means temporary I will be stored in the sum and the level I will be stored in the answer variable. Once queue becomes empty, I will come out of this while loop. I will return my answer. Okay, this is the logic. Let's look at dry run. First it is a base condition. Okay, we are checking the root is empty or not empty. In this root is not empty, so we will be creating a queue. After that, we are taking three variables. Your answer will be at 1 and sum we are storing minimum value and level will be at 0 at starting. Here what we are doing, we are pushing the root in the queue. Means 1 is pushed in the queue. Now checking queue is empty or not empty. It's not empty because 1 is present. So we are incrementing the level by 1. The size value of queue is now 1. The result we are taking. It is a temporary variable. Okay. Result starting will be stored 0. Now we are starting to iterate the for loop. Here the for loop will iterate one time. Okay. And our front element is 1. We will be stored in the node. Okay. After that we will be pop out from the queue. See 1 will be stored in the node. Okay. That result we will be adding. The node value is 1. Now the result is 1. Okay. Now we are checking these nodes left and right child are exist. Yeah, it's exist. If exist means just we will be pushing the queue. 7 and 0 are pushed in the queue. Now the for loop condition will become false. So we'll come out of this for loop. Now we are checking the if condition. Here result is 1 and sum is minimum value. Yeah, the condition is true. So my result will be updated in the sum. Now sum will be changed to 1. The answer in the level what is there we will store in the answer. The level is 1. Okay, that will be stored in the answer. Now checking the condition again. Queue is empty. It's not empty because 7 and 0 are present in the queue. So now level will be 2. The result will be 0. Okay. Now the for loop will iterate 2 times because 2 levels are in the second level. There are 2 nodes. So it will be iterate 2 times. Now the front node is this 7, okay, that we are storing in the node. After that we will be pop out. Now in the result we will be storing the its node level. The result will be 7 now. We're checking 7's left and right child are exist. Yeah, it's exist. 7 and minus 8. Just we will be pushing the queue. 7 and minus 8. Now again we are checking the condition. 1 is less than 2. Yeah, the condition is true. Now the front element will be this 0. That's 0 what we are doing. We will be stored in the node. After that we will be pop out. We will check its left and right child are exist. Here its left is null and right is null. So we will not push in the queue. What we are doing now? We are storing the in the result. The result already is 7. We are doing 7 plus 0. We are getting 7. Now we are checking the condition. 2 is less than 2 will become. The condition will become false. So we are coming out of this for loop. Now we are checking the if statement. Here if condition is the result is here 7 and the sum is 1. The condition is true. So what we are doing? We are updating these values. So the sum will become 7 and answer will become the level is 2. Answer will become 2. Now we are updating. Sum is 7 and answer is 2. Now checking the while loop. Here while loop is not empty because 7 and minus 8 are present. So now level will be incremented to 3. Starting result value will be 0. Now for loop will iterate 2 times. Okay. The front element is here 7. We will be stored in the node. After that we will be pop out. This node value we will be stored in the result. The result will be 7 now. We are checking its left and right child are exist. Okay. Here its left is null and right is null. So we will not push in the queue. Now again we are checking the for loop condition. 1 is less than 2. The condition is true. Now the front element is minus 8. That we will be stored in the node. After that we will be pop out from the queue. In the result, we will be added this minus 8. 7 minus 8. We will get result minus 1. Okay. After that, we will be checking its nodes left and right child are exist. Its left child is null and right is null. So we will not push in the. Now we are checking the for loop condition. 2 is less than 2. This condition will become false. So we'll come out of this for loop. Now we are checking the if condition. The result is minus 1 and the sum is 7. See, this condition becomes false. So we are returning our answer. Answer what is there? 2. So we are returning 2 as our answer. Okay, this is the dry run of this logic. Next, we can understand the time complexity and space complexity of this logic. The time complexity is big of n. Here, next, we can understand the time complexity and space complexity of this logic. The time complexity is taking big of n. Here, n is the total number of nodes in the binary tree. Here, we are using for loop to traverse all the nodes. So, it is taking the time of big of n. When it comes to the space complexity, it is also taking big of n. Here we are using queue data structure to store all the nodes. This maximum level of nodes it will be stored in the queue. So it is taking the space of big of n. Next we can run the code. Yeah, this is accepted. Next we can submit. Yeah, this is submitted solution. Thank you guys for watching my video. If you like this video, please give the like.